All right, everyone, I thought we would go over the test. Number one, which information best supports the inference that the universe began with an explosion? Your answer is going to be cosmic background radiation. Cosmic background radiation is radiation left over from the Big Bang. Two things we have to remember when we're thinking about how we know the Big Bang occurred. The first one is cosmic background radiation, and the second one deals with the wavelength and how it changes when you're moving toward or away from something. It's called the Doppler effect, and that is dealing with the blue shift and red shift. Why is the surface of Mercury covered with meteor impact craters while Earth's surface has relatively few craters? We have to think about the Earth's hydrosphere and the Earth's atmosphere. When we're talking about the hydrosphere and the atmosphere, we're talking about weathering agents. So wind and water is going to erase whatever is left on the surface over some time. A blue shift in the light from a star indicates that the star is moving closer to Earth. Remember, if you have, let's just say, some sort of light bulb, and that light bulb, we know, is going to emit light. And that light goes around, and these are all supposed to be equidistant from each other. They're not. Now, if this light bulb is going to move in this direction, we know that the waves, this is your light bulb, if it's moving in this direction, we know that it's going to be compressed in the front, and in the back, it's going to get longer. So over here would be a red shift. And over here is a blue shift. Because if you look at our ESRT, we can see that the wavelength increases. The wavelength increasing wavelength toward the red end, and decreases toward the blue or the violet end. Number four, we know that Earth is revolving around the sun because we have different seasons. We will be covering that at a later date. Number five, scientists infer that most of Earth's earliest atmosphere was produced by, in the beginning of Earth's history, what you had was a lot of volcanic activity and magma at the surface of the Earth, or lava, and they emitted lots of gases. And that's one way that we know what the early atmosphere was made of, by looking at what comes out of volcanoes now, because we assume that that happened in the past also. However, later on, we know that oxygen was introduced by looking at what occurred. We could look at our ESRT, and we could see that oxygen, we could see that oxygen here we're having difficulty, but oxygen-producing organisms created the first oxygen-rich atmosphere, which led to our Cambrian explosion. The arrival time of the first P wave was 10:11:12. The epicenter of the earthquake is 8,000 kilometers away. What was the approximate arrival of the S wave? We go to the ESRT, and we find the P and S wave chart. On the P and S wave chart, we know it's 8,000 kilometers. So an earthquake first occurred here over a bunch of time. At 8,000 kilometers, the first P wave hit. We know an S wave is going to hit that same location. So we have to count the time from here up to here. You take a piece of paper, you mark it, and it comes to about, I think, 9 minutes. So if there's a 9-minute difference, and it was 10:11 20 plus 9 minutes is going to actually give you, the answer is not 2. The answer is 3. For 7, we know that shaking over here is going to cause the most damage. That is called liquefaction. That is liquefaction. Make sure that you know what liquefaction is. The greatest earthquake hazard occurs in silt and mud. Number 8, which tectonic boundary best represents this diagram? We know right here we have the oceanic crust, and it is subducting underneath the continental crust, which is going in this way. So we know that this is a convergent plate boundary. If we go to the ESRT again, we're going to look to see where there is a convergent plate boundary. And right here, we could see that this area is converging with the North American plate. So it's the Juan de Fuca and the North American plate. Compared to the oceanic crust, the continental crust is. All right, so what do we have to do here? We go to the ESRT again. We go to the inferred properties of the Earth's interior. And we know that the inferred properties of the Earth's interior, we look at this section here, and it says granite is 2.7 and basalt is 3.0. Therefore, we go here, and we know that oceanic crust is basalt, and that it is more dense. Now, is it more or less mafic is the question. All right, so oceanic crust is more dense, so the continental crust is less dense, and it is more felsic. You would find that answer by going to the ESRT. Excuse me. And you go right here. So we know that granite is felsic and basalt is more mafic. So that was the first 10 questions. We're going to do another 10 in a moment. Thank you for bearing with me.